In this video, we'll analyze side effects that require a cleanup when their work is done, such as running timers using setInterval. We'll learn to handle such side effects using the component will unmount lifecycle method. So let's begin. In the last video, we saw an example of implementing side effects such as fetching data from an API in a class component. We also have side effects such as running timers using setInterval or using subscription-based services for getting real-time data. In these cases, once you instantiate the service in a component didMount function, it persists until explicitly removed when the component is destroyed. Therefore, such side effects require cleanup once the component is unmounted and destroyed to prevent memory leaks and performance issues. React provides us with the component will unmount lifecycle method in class components, which can be easily used to unsubscribe from services, detach event listeners, or remove timers. Let's look at an example where we'll set up multiple timers and implement the component will unmount method. As always, download the project archive from this link, extract to a folder, and install dependencies. I have my hot reloading server up and running already. Our app component here includes an array variable named timers. On typing a title in the input box here and pressing the enter key, a new instance of the timer component is rendered on the UI. Every timer instance is created on the basis of an object where the ID property is a unique value computed using the UUID package, and we have a name property which is set to the text that the user has typed in the box. This way, you can create multiple timer instances, each of which will run independently. You can also remove timer instances by pressing the remove button like so. The timer component requires two props besides the key attribute. The name prop carries the text which is displayed on the timer instance, while the onRemove prop is used to invoke the remove timer function, which removes a given instance from the timers array and consequently from the UI. Now, the timer component is also a class component which currently renders a static UI for the timer. We are using the name prop to display the name or the title of the timer. And we are currently displaying a static and formatted timer value of 2000 seconds. The formatting is being achieved using the moment.js library, which is already listed as a dependency in our package.json file. The format time function requires total seconds as a count, which it converts to hours, minutes, and seconds for our display. We also have a play and pause button, which will allow us to pause the timer and resume, and we have our remove button, which I've already hooked up to the onRemove prop. We'll begin by adding a state variable named seconds, and I'll initialize it to 0. We'll increment this every second, and this is our basis for the timer. This seconds count is then displayed as time elapsed using the format time function. I'll also create a property called isPaused, which we'll set to false as default. When this is true, we want our timer to pause the count until we resume manually by clicking the pause button again. To get the timer running, I'll use the component didMount method. Here, we'll create a component instance variable named this.timer instance, and we'll use setInterval, which is set to run its callback every 1000 milliseconds or 1 second. The reason we are using this.timer instance here is because setInterval returns a numeric value known as interval ID. We can use this to cancel the timed action that the setInterval creates. Since the setInterval instance is typically available on the window interface that the browser provides, it needs to be manually cancelled. Now, within the setInterval, we'll check to see if this.state.isPaused is false, and if so, we want to increment the seconds property by 1 every second. This way, our timer keeps running all the time, but we just pause or resume incrementing the seconds property based on the value of isPaused. Finally, we'll display this.state.seconds after formatting it using the format time function. Let's now create a timer named boil an egg like so. As you can see, our timer starts right away. To pause and resume the timer, I'll add an on-click event listener on the pause button, and we'll use this.setState to toggle the value of this.state.isPaused, like so. This, as you can now see, lets us easily pause and resume our timer. Now, once we have the set interval timer running on the window interface of the browser, it'll keep running unless manually removed. If at this stage you do not implement a cleanup, then you'll just keep on piling up instances of set interval that'll keep trying to run its callback function even though the component instances may no longer be in existence. This is where cleanup is necessary. To clear out set interval instances, we'll use the component will unmount function where we'll use clear interval passing in the interval ID that is stored in this .timer instance. This effectively cancels and removes the set interval instance whenever the component is destroyed and removed from the DOM. One last thing that I'll add here is a simple ternary expression that will display the word paused if your timer instance is paused. And as you can see, it works perfectly. In this example, we created an application that allows you to create multiple timers which can be independently paused, resumed, and removed. When removing timer instances, we used the component will unmount lifecycle handler to cancel the instance of set interval being used by the component. This is critically important in cases where you're using timers, subscription services, or event listeners which need to be removed along with the component instances. Now, while we used a class component here to demonstrate side effects that require cleanup, function components can also implement similar cleanup mechanisms by using the hooks API. In the next video, we'll take a look at the synthetic event system in React.